Today we're going to start talking about the imaginary number world, which is called complex numbers. So we have been solving quadratic equations and solving for x. So if we look at this first example up here, if I were to solve for x, I would subtract 12 first, right? So I'd have x squared equals -9, and then I would square root, right? But what's the problem? I can't take the square root of a negative number, so in the real world, this no longer works, which is why mathematicians came up with the imaginary number system. So this right here is an example of our number system. Our number system, we have only ever focused on the left side, which are the real numbers. The real numbers consist of everything we've learned before. Rational numbers, which are fractions, integers, whole numbers, irrational numbers like pi or imperfect square roots. But now we have to talk about the imaginary number system, which is just a plus bi. Okay? So an imaginary number is a number system created to overcome this problem of taking the square root of a negative number. So imaginary number is a number system mathematicians created to overcome this issue. And the issue is the square root of negative number. So the square root of a negative number is just an imaginary number. So we use the letter I. I is an imaginary number because that's the symbol we denote for imaginary. And the square root of -1 is I because the square root of 1 is 1. And whenever you have a negative square root, you're going to take it out and make it an I. So if I were to look at example 1, the square root of -1, that's just a negative becomes I. And the square root of 1 is just 1, so I'm done. When I have the square root of -9, the negative inside becomes imaginary, and the square root of 9 becomes 3. If I look at number 3, the square root of a negative becomes imaginary, and the square root of 25 is 5. And if I look at example 4, the square root of -20, well, I can't do 20, but I know the square root of a negative is imaginary. So now I got to figure out the biggest perfect square that goes into 20, which is 4 and 5. So the square root of 4 is 2. So 2i rad 5. So if I were to do 5, the square root of -24, so negative becomes an I. That comes out. 4 and 6, square root. So it's going to be 2i rad 6. Okay? I go ahead and we keep going here. Now let's talk about solving. So I'm going to go ahead and I'm going to solve. So I want to get x by itself. So I'm going to square root. So x equals plus or minus the square root of -99. I can't have a negative square root, so I'm going to take that out and become an I. Square root of 99, I have to simplify. So it's going to be 9 and 11. Square root of 9 is 3. Square root of 11 is 11. So I have x equals plus or minus 3i rad 11. If I look at number 2, to get x by itself, what do you think I'm going to do first? Well, I'm going to divide by 6. So I'm going to do 324 divided by 6. I get x squared equals -54. Square root. So x is going to equal plus or minus. Negative becomes an I. Square root of 54. 54 goes into 9 6 times. So that's 3i rad 6. So I want you to go ahead and I want you to pause this video and I want you to try number 3 on your own. And when you finish number 3, I want you to unpause it and I will go over it. So I'm going to first add 108 to both sides. And then I'm going to do 108. I'm going to divide that by 4. So I get x squared equals -27. So now I'm going to square root. So x is going to equal plus or minus. The negative square is going to become imaginary. And then I'm going to break up 27 and say 9 and 3. So it's going to become plus or minus 3I rad 3. Hopefully you're doing okay. Let's go ahead and keep going. Let's talk about what it means to be a complex number, because that's where the imaginary numbers live. They live in the complex number system. We have the real number system, and then we have the imaginary number system, and the complex is made up of all of it. So complex numbers, they are a number that consists of a real number I'm going to say a real and imaginary number. So for standard form, that just means it's in the form a plus or minus bi. That's all that means. So a is my real number, so 2, 3, 4/5. bi is my imaginary number. So we have to learn first off the basics. So like we're going back to kindergarten with math, we have to learn the basics. We have to first learn how to take the sum and differences of complex numbers. So with the sum and differences, all you do is CLT, combine like terms. So I combine like terms just like I is like a variable x. It's the exact same thing. So if I look at example 1, I'm going to go ahead and I'm going to add my like terms. These parentheses are totally unnecessary because I just have positives outside of them. So I'm just going to go ahead and add them. So 2 and 4 make 6. 3i and 2i make 5i. And to keep it in standard form, your real number has to come first. Your imaginary number has to come second. So be very careful. If I look at the next one, I have this minus, I'm subtracting them, which means I have to technically distribute -1. So I'm going to have 12 plus 6i minus 6 minus 3i. And now I'm just going to combine like terms. 12 and -6, that makes 6. 6i and -3i, that makes 3i. And I'm done. So go ahead and pause this video and try number 3 on your own, and then we will go over it. So the first thing I'm doing is I'm distributing that negative on my last parenthesis. So now I'm going to go ahead and combine. 8 plus 9 minus 19. 8 plus 9 is 17. Minus 19, that's -2. And I'm going to cross them out so I use them. 11 and -7i make 4i. 4i and 3i make 7i. So now we're going to go ahead and we're going to start talking about multiplying complex numbers. Multiplying complex numbers gets a little more complicated. Multiplying complex numbers. Okay? When I'm multiplying complex numbers, I have to remember that I equals the square root of -1. I am never allowed to leave an exponent on I. Never leave an exponent on I. Why is because it can be broken down to be simpler, which is why it is never allowed to leave an exponent on I. So how I'm going to do that is I'm going to have to memorize patterns. So I equals is the square root of -1, right? So I squared is just the square root of -1 times the square root of -1. Well, the square root of -1 times the square root of -1, that's just -1, right? Because square root of -1 times square root of -1 is whatever's underneath it. So then what do you think I to the third is going to be? Square root of -1 times the square root of -1 times the square root of -1. So I know the square root of -1 times the square root of -1 is -1. And I know the square root of -1, well, that's just I. So that's -1i, which is just -i. I to the fourth is the square root of -1 times the square root of -1 times the square root of -1 times the square root of -1. And I know these these two square roots of -1 make -1. And I know these two square roots of -1 make -1. So that just makes 1. And then I'm going to keep going in cycles here. So if I add an extra square root of -1, so -1 times square root of 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 -1, I know I to the 4th is 1, right? Because that's what I just got previously. And the square root of -1, that's just I, so that's just I. And I to the 6th, again, if I go and I keep going to 6, 1, 2, 3, 4, 5, one more with my chicken scratch. I know I to the 4th makes 1, and I know I to the squared makes -1, so I to the 6th is -1. And I'm going to do the same thing with I to the 7th. So I to the 7th, -1 times -1 times square root of -1 times square root of -1 times square root of -1, 2, 4, 5, 2 more. I know I to the 4th makes 1. So now I'm left with I to the 3rd, and I to the 3rd was just -I. So what do you think 8's going to be? 1. Because if I add one more, I have 1, 2, 3, 4, that makes 1, and 1, 2, 3, 4, that makes 1. So there's a jolly pattern that follows with this, which is why you only have to memorize these 4. Right? And I to the 1st power, we're just going to not call that -1. We're just going to call that I. We are helping you out there. So I have to memorize those 4. I to the 1st is I to the 2nd is -1, I to the 3rd is I to the 4th is 1, and that way they always will repeat themselves. I don't want to have to do this. I don't want to have to write I to the -1 12 times. So instead, I'm going to find the closest multiple to 4 that that exponent is, and then I'm going to determine what my remainder is. And why I'm using 4 is because I to the 4th equals 1. So when I to the 4th equals 1, it makes my life so much easier that it's just going to be 1. It's going to be gone. So if my exponent is divisible, or 4 is divisible by that number, then my answer is 1. If it's not divisible by 4, then I have to determine what the remainder, I have to force it to be to have a remainder to determine my answer. So let's just go through this and you'll catch on pretty quickly. I to the 12th. So if I look at my exponent 12, does 4 go into 12? Yes. Done. My answer is 1. Because 4 goes into 12, so my answer is I to the 4th. Let's look at number 2. Number 2, I to the 25th. I to the 25th, 24 going to 25? No. So I have to break this up and I have to find the closest number to 25 that goes into, that 4 can go into. Well, 24 can go into that, so I can have I to the 24th, and then what would my remainder be? I to the 1st. So because this is a multiple of 4, this makes 1. That's just 1 times I to the 1st, so I can just get rid of it. I to the 1st, that's just I, and I'm done. Let's look at the next one. I to the 104th. Does 4 go into 104? Yes. Done. My answer is 1. Does that make sense? If I look at number 4, 252. Does 4 go into 252? Yes. Done. My answer is 1. Which is why I never am allowed to leave an exponent on I, because they can always be simplified. Let's now go ahead and let's look at your back. So let's start practicing multiplying. I'm going to go ahead and I'm going to distribute. All right, that's what I have to do. So 4i times -6, that's -24i. And 4i times I, that's going to be plus 4i squared. If I leave my answer like this, I'm going to lose a point because I has an exponent. I squared is equivalent to what, according to my table back there? -1. So now I'm just going to do 4 times -1, which is -4. So I have -24i minus 4. If I leave my answer like this, I'm going to lose a point because it's not in standard form. Real comes first, and then imaginary. If I look at number 2 I have to double distribute because I have 2 sets of parentheses. So 9 times negative 4, that's negative 36. 9 times 7i, that's 63i. Negative 2i times 4, that's plus 8i. Negative 2i times 7i, that's negative 14i squared. So I see I squared, I circle it. I squared is equivalent to negative 1. So this becomes positive 14. And then I'm going to write down everything else. And now I'm going to combine like terms. Negative 36 and 14 make negative 22. 63 and 8 makes 71i. So I want you to go ahead with this concept, and I want you to pause 3 and 4, and I want you to try them on your own, and then unpause it, and we will show you the answer. So 3 is just backwards distributing, so this is going to be 8i minus 14i squared. I know I squared is equivalent to what? Negative 1. So whenever I have I squared, I scribble it out and I just change the sign, because that's all that's happening. So it's going to be 14 plus 8i. That's a fun trick for you. And then if I look at 4 and I double distribute, I have 9 plus 6i minus 6i minus 4i squared. I see I squared, I scribble it out, I change the sign because I squared is negative 1 and it's just going to change the sign. So my 6i's are going to cancel out, so 9 plus 4 I'm left with 13. So now let's talk about dividing complex numbers. Dividing complex numbers is the most, what people say, the trickiest. So the trickiest is how I divide by complex numbers is I have to rationalize the denominator by multiplying by the conjugate. So I multiply by the conjugate. We know rationalizing, we saw rationalizing the denominator when I had a square root in the denominator. So now how I do this is I want to multiply by the conjugate. The conjugate, I put it in a different color, that is just the opposite of the imaginary spell of the imaginary number. Okay? So if I look at these examples, it wants the conjugate. I just want the opposite of 6i. The opposite of 6i is negative 6i because that's the only imaginary number. If I look at number 2, 5 plus 6i, the conjugate is just the opposite of the imaginary number. So it's just going to be 5 minus 6i. And if I look at number 3, the conjugate is going to be what? Negative 5 minus 9i. I'm just multiplying, taking the opposite of the imaginary number. The conjugate is how I rationalize the denominator when it's imaginary. So if I go down here and I look at these examples, it says when you multiply by complex by the conjugate, you get a real number. So let's practice. So what's the opposite of 4 plus 3i? It'll be 4 minus 3i. And I want to multiply these two together, so I have to double distribute. So I have 16 minus 12i plus 12i minus 9i squared. I see I squared, I scribble it out and do what? Change my sign. So my 12i's cancel out. 16 plus 9, 25. So go ahead and try the next one. My conjugate's going to be what? Negative 5 minus 12i, and then I put my first terms in parentheses. So I know to double distribute. So I have 25 plus 60i. Oops, it's not negative 12 minus 12i, it's negative 12 plus 12i. Let me back up. So negative 5 times negative 5 is 25. Negative 5 times 12i, that's negative 60i. And now I'm going to distribute this way. So it's going to be plus 60i. And then it's going to be minus 144i squared. the I squared, scribble it out and do what? Change my sign. So my 60 i's are going to cancel out. So I have 25 plus 144, which is 169. So if I actually do the fun part now, I'm actually going to now actually divide. So notice I have two complex numbers and I want to divide. So how do I divide? I multiply by the conjugate. So the conjugate is what? The conjugate is 1 plus 4i and 1 plus 4i. So I'm going to double distribute on the top. So I have 7 plus 28i plus 5i plus 20i squared. I scribble that out and change my sign. So now I'm going to distribute the bottom. 1 times 1 is 1. 1 times 4i is 4i. Negative 4i times 1 is negative 4i. And negative 4i times 4i is negative 16i squared. I'm going to scribble out I squared and change the sign. So now I'm going to clean some stuff up. 7 and negative 20 make negative 13. 28i and 5i make 32i. All over. If I clean up the denominator, my 4 i's cancel out, and 1 plus 16 is 17. And I'm done because 13 over 17 I can't simplify, and 32 over 17 I can't simplify. So I know I divided correctly because I no longer have an imaginary number in my denominator. If we go ahead and we do number 2, I'm going to multiply by the conjugate, and my conjugate is 2 minus I. It's the opposite of the imaginary number. So I'm going to double distribute. So I have 12 minus 6i plus 8i minus 4i squared. Scribble out I squared. It's equivalent to negative 1, so I change the sign. And then I'm going to distribute the bottom. I have 4 minus 2i plus 2i minus I squared. That scribbles out and changes, and since I have just a plus, it's going to be plus 1. So I have 12 and 4, which makes 16, and then I have plus 2i all over. My 2i's cancel out. 4 plus 1, that makes 5. So 16 over 5 and 2i over 5, I can't simplify, so I am done. And if I go ahead and I do this very last one, I'm going to multiply by the conjugate, which is 3 minus I, and then I'm going to double distribute. So I have 24 minus 8i plus 12i minus 4i squared. I squared is equivalent to negative 1, so I scribble it out, change the sign. 3 times 3 is 9. 3 times negative I is negative 3i plus 3i minus I squared. Scribble out, change the sign, so I'm left with a plus 1. So if I look at my numerator, 24 and 4 make 28. Plus 4i. My 3 i's on the denominator cancel out. I'm left with 10. If I leave my answer like this, I'm going to lose a point because notice all 3 of these are even. So I can divide everybody by 2. So I have 14 plus 2i all over 5. You know you did this correctly when your imaginary number cancels out in the denominator. So the rest of your homework is to practice these 8 practice problems. You must complete these last practice problems to get credit.